I want to give a short introduction. Last year, when I traveled to this Ubuntu Summit in Riga, I met George-Andrei on the flight from Vienna to Riga, and we had a nice in-flight session. He was suggesting me as the leader of open printing to apply OSS-Fuzz testing to open printing. And as I'm very busy managing open printing, I had not the time to do it by myself. And so I opened an Google Summer of Code project. I'm every year mentoring in the Google Summer of Code, something like 5 or 6 students. This year we had even 11. And this year I opened a Google Summer of Code project about applying OSS-Fuzzing to open printing with George-Andrei as the principal mentor. And we succeeded. We found a great candidate for it, Jiongxi, and the Google Summer of Code at Google, the Google Summer of Code program managers, they wanted to help security-related projects. And so they have given us an additional mentor, and this additional mentor is Dongge. And this is how it all worked out. Jiongxi worked really well, and all the 3 worked in a great team. And this was really, this year from all the 11 projects, the best one for open printing. And as a result, they came to the idea to give a workshop to teach to all of you that you can also apply OSS-Fuzzing to your own free software project. So then, let us start.
Thank you for the introduction, Till, and thank you all for being here. Let me start with the most important question for this introduction, namely if you have the setup already done. If not, I guess you already have Python 3 and Docker already installed on your systems. So just run the 2 commands on the bottom, namely git clone for OSS-Fuzz. It should take like 1 minute with the internet connection that we have here. And cloning the last repository, which is basically hosting the files for this workshop. And I will wait 1 to 2 minutes for you to do this. Is there anyone who still needs to copy these comments, or can I go to the next slide? Please raise your hand if this is the case. Okay. By the way, you can also find this command on the description from Canonical Syndico. So from the event listing. Okay, this being said, let's have a brief look into what we will discuss in this 1 hour and a half. We will start with a quick introduction into fuzzing, into what this concept assumes. We will talk about OSS-Fuzz, and we are lucky because we have Dongge here, which is basically developing OSS-Fuzz. We will have a practical part, which means that we will discover Heartbleed, a really well-known vulnerability, by using OSS-Fuzz with the OpenSSL codebase. We will have Zhengxi, who will join virtually to explain how he leveraged OSS-Fuzz to integrate the open printing projects into the fuzzing infrastructure. And in the end, we will talk about how LLMs are now used for fuzzing in the context of OSS-Fuzz-Gen. Dongge, do you want to join to?
Yeah. Thanks, Andrea. So this is me. That's a picture of mine. I'm working on OSS-Fuzz-Gen, which is derived from OSS-Fuzz. I'm also a maintainer of OSS-Fuzz. It was developed way before I joined. I'm also maintaining another repo from our team. It's called FuzzBench, which is helping researchers to improve their fuzzers. So I also have research interest in cybersecurity and machine learning. That's all info of mine.
Hi, as the person before mentioned, I'm Andrei. I'm currently a security engineer in Snap. I'm a GSOC mentor, a startup advisor. I love coffee and outdoor sports. And I also was a member of the Ubuntu security team. And Zhengxi, who is joining us virtually, is a PhD candidate in computer science in Singapore. He worked for integrating the open printing projects into OSS-Fuzz, and he's doing research in cloud native testing and security. So let's start by talking about fuzzing. And I want to give you this really complex definition of fuzzing, and I provoke you to understanding. So fuzzing is a dynamic software testing mechanism that runs in an instrumented and optimized fashion. The software under test through its harness with tailored, eventually random, formatted or unformatted, eventually based on an initial corpus input, to detect unexpected behaviors such as crashes, assertions, memory leaks, race conditions, and undefined behaviors. This is easy, right? Easy to understand. I know that it's not, so let's look at this diagram that I have here. What we are interested in is testing our software, right? So this is called, in the fuzzing jargon, the software under test. To couple this software to a fuzzer, we need some glue code. This glue code is named harness. After we have these two components already set up, then we need to give the fuzzer some test data, namely some data that we know the program is running correctly with. So this is the initial corpus. For example, if we have a PNG parser, then we just download some PNGs from the internet, and that will be the initial corpus for the fuzzer. Then let's start looking into this fuzzer, which is the black box presented in this workshop. We have two main components here, the runtime, who deals with executing the program, and the mutator, which deals with mutating, like changing the input from one stage to the other one in order to execute different paths inside of the program. On the runtime component, we have instrumentation, which is a component dealing with having insight into how the program runs. For example, looking into the registers of the CPU when the program is running, and optimizations, because we are running the same program probably millions of times. So we can use some operating system optimizations, for example, freezing the process and using that snapshot for running again the process to speed up the entire fuzzing session. And on the mutator side, we have randomness, which is embedded in the process. Like we want each stage to have some randomness to explore different paths. And we have the formatter. For example, if we are fuzzing a UDP packet, a parser for UDP packets, then we probably want the IP, for example, to be in a specific format. I don't know, to just be a private IP. So this is the component dealing with this kind of formatting. Then we have Another component inside the fuzzer, which is the watcher, which is able to detect some criteria when executing the program. And these are the cases that are interesting for us, namely the unexpected behaviors, such as crashes, assertions, memory leaks, race conditions, and behaviors. So I hope that this diagram will make the previous definition clearer. To conclude this fuzzing small section, I want you to think about the program like a maze. We have this control flow graph, which is like a path inside the maze. Depending on the input that we are offering, we are basically taking a path inside the maze. So you can basically think about the fuzzer as an autonomous robot which is trying to enter the maze. Initially, the robot will be dumb enough to hit the wall and to not enter through the entrance. So this happens. Like if I have a JPEG parser that I want to fuzz, probably the first iteration will not generate a valid JPEG program, so the parser will do nothing. Then I have some inputs which are valid, so they are entering the maze, they are accepted, but they are parsed correctly. These are cases which are basically thought about by the developers, so they are not of interest for us. But on the other hand, we have these other inputs which are unexpected for the programs. The developers didn't think about them. So these are the crashes, these are the memory leaks, these are the cases that interest us. And concluding this fuzzing small section, I want to invite Dongge to join the stage and to introduce OSS-Fuzz.
Cool, thank you. Right, oh man, thank you. Right, so OSS-Fuzz is a repo that Google created in response to the Heartbleed vulnerability. You might have heard about it. That was back in 2016. Sorry, how did it?
I think you.
Right. So back in that time, fuzzing was still requiring a lot of manual work, and it requires a lot of extensive CPU hours. Google created OSS-Fuzz to fill in this gap. It's a free service for all critical open source projects. Anyone can join, anyone can integrate a new project. And we privately alert all the developers and maintainers about these vulnerabilities we find in their code. So since it launched, it has become a critical service for all impactful open source projects. So now it has grown beyond just C and C++. It can also detect bugs and vulnerabilities in memory-safe languages such as Go, Java, Python, Rust, and Swift.
It should be fine. Don't worry.
So we also want to reward people for their contribution to the community too. There are three main types of rewards we gave to people: integration, coverage, and vulnerability. So for integration rewards, we gave an initial integration reward to people who as a new project, an impactful open source project into OSS-Fuzz. And we also gave an ideal integration reward for if the fuzz target is really impactful and satisfies certain criteria. We reward people for high coverage. If your fuzz target can discover a lot of new lines than the existing ones, so we also give you a coverage reward. And if you have a new sanitizer, or if your fuzz target can find a critical vulnerability, then we can also give you a vulnerability reward as well. So that's all. If you want more info, you can click on that link later.
Okay, then now we can go to the practical part. Probably all of you already have used OpenSSL. And OpenSSL had this really well-known bug like 10 years ago, which was named Heartbleed, which was memory corruption. The SSL server was basically leaking its memory when someone was trying to connect to it. This was the reason why Google started to invest into fuzz testing and starting to introduce OSS-Fuzz to critical open source projects. Namely, hey, if you have a critical open source project that is really important for the internet, then we can allocate our people, we can allocate our compute resources for these projects to be fast. So the internet will be basically more secure in the end. So what this workshop is about is we are assuming that you are one of the OpenSSL core maintainer, and we want to detect we want to detect Heartbleed using OSS-Fuzz. I should mention that some of the steps are infeasible for 1 hour and a half, and this is because, for example, to integrate your project into OSS-Fuzz, you need to create a PR, you need to get the PR approved, so this is unfeasible for this setup, and probably the OSS-Fuzz maintainers will not be happy with having some dummy PRs for a workshop in Hague. So we will skip these steps. We will have some slides, we will see some links, so we will get a grasp about the process, but we will not do the PRs and some other steps. You'll see that the slides will be marked with practical, the things that we can do on our host, and placeholders, which are the slides which are covered by the aforementioned situation. I just wanted to give a small demo of how Heartbleed can be exploited. This is Metasploit. It is already loaded with the module for exploiting it. So the attacker just set the parameters, hit run inside Metasploit. You'll see that the leak from OpenSSL is dumped into a file. And then when the attacker will try to inspect this file, he or she will be able to see some relevant details from the memory, which are things like emails, options, and URL parameters and session IDs. And this is not good because anyone from the internet can basically exploit the vulnerability, can, for example, steal this PHP session ID and can steal the admin account. But going forward, we will start the practical part by initializing the OSS-Fuzz project. And we will do this by changing the directory into the OSS-Fuzz folder that you have already cloned. Then we create 2 environment variables, one for the project name. In this case, it will be OpenSSL-Heartbleed. And we will set the language to C++, because this is the main programming language in which OpenSSL is developed. And please let us know if you have any issue, because we can basically join you and can inspect what issue do you have. Then the next step is to use the OSS-Fuzz helper Python script in order to generate the project. We are using Python infra-helper.py with the generate subcommand. Then we specify in the same command the project name, which is stored as an environment variable. We set the language of the project. And then we change directory into the folder which was generated by this OSS-Fuzz helper script. I need more time for this. Okay, so we can go to the next step, which is generating the OpenSSL certificates. And this is a placeholder slide, so you should not do nothing here because the certificates that we will use are already generated and they are placed inside the workshop repository. So what we did is using the OpenSSL command to generate these X509 certificates. We are basically specifying the parameters for this. Is generating a key in with a specific file name, to a specific path with a certain validity. So the next step that will be practical is filling up project.yaml. This is a file that basically dictates to OpenSSL how to treat our repository. What's the programming language? Who are the people that should be contacted in case a crash will occur? So what you should do here is looking into the project.yaml file that is automatically generated by OSS-Fuzz. You'll see that you have only few parameters already set. So what we will do is copying from the fuzzing in the open folder, which is the repository for the workshop, the already filled project.yaml file into the current file, and then we will take a look into project.yaml. So this is the content that is already filled. And let's have a look while you are running the commands at the content of this file. We are basically setting the home page of the project. We are setting the main repository where the code base resides. We are setting the programming language, which is the one that we previously set as an environment variable. We are setting the primary contact, which will be contacted if a crash or any unexpected behavior will occur. Other contacts that will be CC'd if this unknown behavior will occur. Some vendor emails. You can think here about a downstream operating system that are using your software and you want them to be noticed in case a crash will occur. You need to set the architecture. In this case, there are to accept the values. There are multiple sanitizers. This is the logic that is detecting the undefined behavior. You have one for address, for example. You have one for the address, one for the memory, and one for the undefined behavior. In this case, for this workshop, we are also only interested in detecting that invalid memory access. So we will just set the address one. We are setting the fuzzing engine, namely the part which is dictating how the input is mutated, how the program is run, and so on. You have here multiple fuzzers which are supported by OSS-Fuzz. For example, libfuzzer from libfuzzer, AFL, hongfuzz, and centipede. We will use here libfuzzer. How many builds do we want to have on each day? For example, if your code base will change more times a day, you will be interested in having this value set to a higher value. So 2, but up to 4. This is the maximum value that OSS-Fuzz provides. A link to a help page and a parameter whether to mirror the issues on GitHub instead of having them only in the OSS-Fuzz tracker. So after running the commands from the slide, you will basically have the content that I already presented in your folder that was generated by OSS-Fuzz. Yeah, sure. All right. Do you need more time here? Okay. Then we will do the same process for the Docker file. The Docker file dictates how the image in which the program will be fuzzed will be constructed. And we will do basically the same. We will inspect the Docker file that was initially created by OSS-Fuzz-Gen. We will copy the file that was given by us in the context of the workshop, and then we will look into the Docker file. So if you can make a photo of this comment, if you can't remember it, and then we can jump into looking into the file. So here we are setting the base image, which is the one provided by OSS-Fuzz. It's called base builder. This is an argument that we forgot to take out from the file, so bear with us. After that, we updated the operating system and we installed the dependencies from OpenSSL. We are cloning the OpenSSL repository. We then change the directory into the OpenSSL repository, and we check out at a version that we know is vulnerable to Heartbleed. We set up the Docker work directory to OpenSSL. We copy the build script into the container, and we will see the build script immediately after. And we will copy the runtime folder, which holds the already generated SSL certificates into the container. And having these two files in mind, the next file and the last file that we will copy is build.sh, which is basically dictating how the project will be built in order to be fuzzed by OSS-Fuzz. And we will do the same, like we have an already pre-filled file inside the repository of the workshop, and we will copy that inside the folder generated by OSS-Fuzz. And let's do the same. Let's have a look into the content of this file, and afterward we can basically check if you have any issue with your setup. So the script is small. You'll see that we are setting the LLVM compiler, the CLang program, and the one for C++, CLang++. We are setting the C flags and CXS flags. This will be used by the compiler to enable some options. We then set the fuzzing engine with the fsanitize parameter, which will be passed to the compiler. We build the project with CC, which is the compiler, and the C flags, which are the flags passed to the compiler, and then the config file. We then make. We need to copy the harness, which is another file that we have a look to, which is target.cc inside the fuzzer folder. We then build the harness using that long command, and then we copy the certs, that 40th line, the cp-r, then the runtime folder. So I will have a break from the slides, and I will check if you have any issue. Do you want to give a brief about this?
Right. So here's a minor tip we have when you are integrating a project into OSS-Fuzz. So basically, the tip is do not override these C flags and C++ flags. OSS-Fuzz has some predefined flags inside these two environment variables. If you override them, then you may have some compatibility issues with Fuzz Introspector, which is a tool we use to measure coverage. So yeah, you can append new flags into these two variables, but do not override them, please. Thank you. Yeah. Oh, another tip is that, as you have seen, we have a fuzz target file called target.cc, right? So for simplicity purpose, in this workshop, we are maintaining it inside the directory of OSS repo, right, when you submit a PR. But in reality, when you're integrating a new project, please consider maintaining that fuzz target file inside the project and your test. In this case, will be in OpenSSL. This will help you and the maintainer to update the fuzz target more easily. It doesn't have to go through us. You just do it at any time you like. Thanks.
So then we can think about the last file that we need, which is the harness, which is the file that we already copied and built in the previous Docker files and build.sh. So we will do this. We will do the same. We just copy the runtime folder which contains the certificates, and then copy the target.cc file. And let's have a look together at them. So the runtime folder, as you see here, contains only two files, which were generated by the previously mentioned OpenSSL command. So only the private and the public key. And then the harness, namely target.cc, includes OpenSSL, then uses this complex function in order to set up the SSL context. And you'll be interested here in seeing how the certificates are used. Namely, we use this server.pam as a certificate file, and we are using server.key as a private key. And the harness itself is this specific function. And you should also have a look at how the function is named. And this is specific for libfuzzer. You'll see that we have two parameters, namely data and size. This is the way of the fuzzer in order to tell what data is generated and how lengthy it is. We are calling the previously defined function for setting up the SSL context. We created these two bio buffers. We then can have a look at the fuzz section over there, which is the most important from the whole harness. We are writing the data that we receive from the fuzzer, which is saved in that data variable and also described by the size variable into the bio that we already have set up. And then we do the SSL handshake. In the end, we are freeing the server with SSL free, and then we return. So just think about the previous diagram that we described in the beginning. So if we encounter any issue with this handshake, the program will basically crash in that fuzz section over there, and it will not basically return from the function. So these are all the files that we need for OSS-Fuzz. Now we can verify the file correctness, and we have multiple comments here. Initially, we just run docker build with a -t for setting a tag, and the context will be dash, which is will be dot, which is the current folder. And you should be able to run this without any issue. Afterward, having this image built, we can spin up a container based on that image. We are setting out a volume with the -v parameter, and the program that we want to run is /bin/bash. So we want to get a bash inside the container. The next command will be inside the container, which is also depicted by this string over here. We try to run the build script inside the container. You've seen what the content of this file is. And then we try to run the harness by running this specific file. So having these comments, I've seen that most of you succeed, right? We can move forward and build the fuzzers, but with the OSS-Fuzz infrastructure. We basically run the harness and the fuzzer directly by entering the container and running the command from that. Some of you already discovered Heartbleed with this approach, but what we are interested in is using the OSS-Fuzz commands, which are basically proxy for what the OSS-Fuzz guys are doing on the backend, like on their infrastructure. And for this, we will basically go to the root of the OSS-Fuzz repository, and we are using the helper script again, but this time with the build fuzzers subcommand. We are setting the sanitizers, which is the address one. We are setting the engine, which is libfuzzer, and these details also correspond to the details that you have seen in the project.yaml file. We are setting the architecture, and this depends solely on your system. OSS-Fuzz is currently supporting these three architectures, so please choose wisely what suits for you. And after that, we are setting the project name, which we already have stored inside the environment variable. Okay, so having the fuzzers already built, we can go to the next step, which is running the fuzzers through OSS-Fuzz, the local instance of OSS-Fuzz, and finding Heartbleed. And we are doing this by using the helper script again, this time with the run fuzzer subcommand. We are initially also setting an environment variable called fuzzer name. We set the sanitizer to address. We set the engine with libfuzzer. We set the architecture with the same value that you have been using before. We set the project that we already have saved. Then the fuzzer name. After waiting a bit, you'll see that you'll have a crash. Some of you already had this crash when running the harness script without OSS-Fuzz, but you'll see on the CLI that OSS-Fuzz is reporting that it discovered the crash and the crash file is stored somewhere. This is the location that you want to have in mind, because we will basically look at its content. And you'll see that it's a small file which is triggering a really impactful vulnerability. And I will also have a gift for discovering OSS Heartbleed. I have some Swiss chocolate, so hopefully you'll enjoy it. Okay, so you should have at this moment the crash file generated by OSS-Fuzz. And this is the moment in which we are trying to validate the crash file using OSS-Fuzz and the binary that we have generated. OSS-Fuzz exports a subcommand for the same helper script, which is reproduce. We are using here the project name that we have set in the environment variable. We are using the fuzzer name, and then we pass the crash file. And this is the full path to the crash file, which is reported by OSS-Fuzz. You should look into your CLI, and this was printed out by OSS-Fuzz during the previous command. And the alternative here is running, like entering the container. This is a mistake in the slide. Like the second command should be run inside the container. You should basically enter the container, enter the out folder, and then run the harness executable with the crash file. And in this way, you should basically validate the crash again. To speed up the workshop a bit, because we still have 23 minutes, I want to go to the next slide. Please make a photo for this. You already finished the most important part, which is detecting the crash, and you can run this afterward. So now we are starting to talk about placeholder slides, right? We now have a OSS-Fuzz project set locally, and now we want to submit our changes to the remote environment. So we want to ask the OSS-Fuzz folks to host our harnesses and our project inside their remote infrastructure. The first step here is to host the harness. And this was something that Dongge already mentioned, and I chatted with some of you before about this. Please don't store the harnesses in your folder, in the folder from OSS-Fuzz, but create a separate repository inside your organization, or create a new folder inside the repository that you already have for the solution that you are developing. And this is just because you want to have more velocity. After having these harnesses stored somewhere, you should PR the project files that we have created inside the OSS-Fuzz repository. And Dongge, do you want to describe Pacemaker, which is a good example for a PR?
Oh, sure. Can we go to the link of that?
Yeah.
Right. So this is an example.
Just closer.
Yeah, this is an example from a external contributor. So now this contributor is creating a PR to integrate a new project called Pacemaker. So I'm using this as a good example for how to create a PR in OSS-Fuzz for initial integration, because it satisfies several criteria. I'll go through the criteria with you.
This is the first summary. This one. Or here.
Oh, nice. Yeah. Okay. Right. Okay. So the most important thing when you are integrating a new project into OSS-Fuzz is describing the purpose of this project. For example, the name of it, and in which case it will be used, and why do people think it is critical. And also, please also list the major users of this package or this library. For example, if it's used by some other large packages and it's playing a critical role in the package, or it has very secure vulnerabilities, or very severe security implication, then please also mention that in the PR. It will help us decide whether to accept this PR. And third is list the maintainers approval and fast target PR. So for example, when you integrate your when you integrate your fast target into the upstream project, normally you will ask the maintainer if this is okay to add their project into OSS-Fuzz and fuzz it so that they can receive updates on the results. So once you have their approval, please also tag them, or at least add a link to the approval so we know the maintainers are okay with this thing. Right. So addressing these points will help us deciding whether we want to accept this PR, and this is very important to us. Thank you.
Then, after the PR is accepted, we will have the project built on the remote infrastructure. And we can check the remote build logs. You can enter these links that are on the slide. The first one is from Fuzz Introspector, which is a UI for some of the aspects that OSS-Fuzz generates. And you'll also have a link for a failed build from a project. Can you write the first link on your browsers and access this? So it's introspector.oss-fuzz.com/project-profile ? Project = OpenSSL. And I think you should also be able to access this by just searching on Google Fuzz Introspector OpenSSL, and it's the first link. So let's go together through these details. You will see some details about the project, for example, the language, some useful links. You'll see the logs, which are the most important ones for us at this stage. You'll see other details such as the lines of code, the code coverage, and you'll see that this is 41%, so there is some space for improvement. You'll see some graphs illustrating things like code coverage, the number of fuzzers, code coverage per function, and static reachability. And the nicest part, in my opinion, is that you also have some recommended functions that you can fuzz. So if you like, for example, OpenSSL as a project, you can basically look at this list of functions, and you'll see that some of them have 0% coverage. So if you want to contribute, you can basically choose one of these functions, create one harness for these specific functions that you are choosing, submitting the harness to OpenSSL in a PR, and then this will trigger OpenSSL OSS-Fuzz to take your harness and execute that. So in this way, you are basically increasing the coverage for OpenSSL or any project that you are fuzzing. I wanted to highlight here also the fact that you have the build logs. If you are clicking this one, build status fuzzers, you'll see something that you are usually getting inside your CLI. Let me increase this a bit. Doesn't work. Yeah, this is the page is still loading, but if you are accessing this this file on your host, it will hopefully load, and you'll see that these are the comments that are executed by OSS-Fuzz when trying to build your project remotely. Sorry. It freezed. Yeah, in the meantime, please access Fuzz Introspector and have a look until the internet gods will be in my favor. So after doing these steps, you will hopefully get some mails from OSS-Fuzz. And these are noticing you about some crashes, about some undefined behaviors which were met by the fuzzers. And this is also a placeholder slide, so you will not receive an email, unfortunately, but you'll be able to see the template of the email using this link. I will do this from here. It's not the report for Heartbleed, because this was before OSS-Fuzz was developed, but this is for another bug, which was discovered by OSS-Fuzz inside OpenSSL. And you'll see the type of the crash, you'll see the crash location, you'll see the state, the sanitizers which are used, in this case, the same sanitizer that we have used, which is the address one, the recommended severity, revision. Probably the most important part here is the test case, namely the input, which is triggering the crash. So you can basically download this and replicate the crash locally, and other details. So if you would have introduced OpenSSL in OSS-Fuzz before Heartbleed was detected, fortunately, Heartbleed would have generated one of these emails. So the next step after you receive such an email is patching. And this is the last practical slide that we have in the workshop. For here, I want you to have a look into this file, this Git patch from the workshop repository. To modify the Docker file for applying this patch, and you just need to uncomment some lines, and then rebuild. And let's have a look together at the patch file, which is this one. I just have looked into the Ubuntu security page, got the patch link, and this is the same file except a changes file which was not applying correctly for this checkout that we have inside the workshop. And you'll see that the code maintainers were basically introducing some new checks for the parameter which was triggering Heartbleed. And based on the fact that we have 11 more minutes, I want you to have a look at this and run the comments by yourself. So after following all these 4 steps, Heartbleed is basically patched on the code repository that you have inside the container. So you should not have a crash anymore when running the fuzzers. And I want to continue in the remaining part with the other topics that I want to discuss in this workshop. And this is the moment when we will have the other mentor joining from the remote setup. And he will describe us how the OSS-Fuzz integration looked like for him in the context of Google Summer of Code for Open Printings projects.
Hello, you guys can hear me? Yes. Okay, I'll just share my screen. No, okay, I'll just start. So yeah, thanks Andrew for the introduction and for the useful workshop. And hi everyone, I will introduce myself again. And I'm George-Andrei Liu from Singapore Management University. And I was very fortunate to work with Theo, Andre, and Dongge on the GOSST project into migrating open printing project into OSS-Fuzz framework. So it has been a pleasant journey, and yeah. So during the integration, we do have some insights that are served as a valuable feedbacks for the developers, especially for the open source developers. to secure their open printing their open source project, and yeah, especially for those less tested and for those developers are not very familiar with security stuffs. So I will briefly introduce our integration experience and share my implementations for open source community. So yeah, GSOC is a event started from Google, and it has helped to secure the open printing with integrating unit tests and the CI tests previously, and yeah, mostly supported by Teal, I suppose, and organized. And yeah, here's an example that previously for libcups filters, GSOC has supported the mentor and the mentee to integrate the CI test I remembered into the overall framework. And also, so OSS-Fuzz has demonstrated its effectiveness in securing the OSS projects, and especially for GSOC, it has also integrated in several projects to secure their securities, such as Nginx, PostgreSQL, etc. So in previous years, it has been adopted. And yeah, regarding open printing, I will just briefly introduce open printing from my perspective. So open printing is actually the open source organization focused on standardizing the printing support for Linux and Unix-like systems, as you have, or actually, I suppose, may use, especially for Ubuntu. So it's providing printing drivers and printing filters, etc. So all the printing stuffs. And from my perspective, I look into the open printing project, and I found that 20 out of 37 projects are mainly implemented in memory-unsafe languages, specifically for C and C++. And that's actually the motivation for Teal and Android to first come up with the idea to integrate the project into OSS-Fuzz framework, as Fuzzing has demonstrated its effectiveness in detecting bugs, especially for memory-unsafe languages, because it can couple with like different sanitizers, including memory sanitizers and address. Yeah, you might have experienced during the hands-on part in the workshop. And after the code review, we find that the open printing project currently lack of sufficient fuzz testing. And so the overall testing status for open printing currently is just integrated some unit test, which is written by the developers, and very minor setups for fuzz testing, but mainly depending on the AFL settings, which are only running on the local machines, but not actually running the scaled domains, comparing to the OSS-Fuzz and cluster fuzzing frameworks. So although open printing projects are less tested, and especially for the fuzzing, so the security of open printing is very important. I can take some examples. That first, many widely used softwares are developed based on open printing projects, such as GTK, GNOME, or LibreOffice. So this project actually mainly rely on, built on cups, and may introduce cups as their third-party libraries to support their functionalities. And also, especially when Ubuntu Summit, that project for open printing specifically for cups are pre-installed in Ubuntu releases. So actually, when you are running Ubuntu operating systems, then you can find the cups service in your operating system. And there's also a very famous vulnerability issue that I suppose most of you guys may have heard, that it's the recent remote code injection bug reported by Mr. Memory-unsafe, I suppose. Yeah, so it involves multiple call traces of the bugs, and actually the calling chain is settled in different projects into the open printing project. So it's multiple calling traces. And it's actually our goal in detecting such bugs during our integration, but yet we are limited to the interactions process, and we do not like integrate most of the project into the OSS-Fuzz framework, which are currently working on. And our goal actually is to cover the full coverage of the Open Printing project. And actually, these bugs should have been detected before the exploitation. So much for Open Printing briefings. I will introduce my experience in integrating Open Printing project in OSS-Fuzz. So actually, currently we have integrated 3 successful projects into OSS-Fuzz framework, which are first for cups, which has actually been previously developed by another developer, but it's not very complete. And we refined it, and we detect more bugs. And we integrate libcups, which is the library-based repo for cups, and it's widely used as well. And for cups filters, which are, I suppose it's mainly developed by Teal, and it's used for providing different filtering functions for the printing services. So actually, before that, we decided the priority for the project based on the GitHub stars. But actually, after the integration, I found that the priority should focus on like the popularities and or the usabilities of exploit, which means the severity of the bugs. That should be valued as a more like matrix for selecting the project. So we are actually migrating the cups filters and libcups filters. We have written the harness, and we are looking forward to migrate it into the OSS-Fuzz afterwards. And for the cups browser, I think the severity of the bugs actually worse nationally, and the previous RCE bug is also caused by such repo. So yeah, this project we are currently working on. So I will just introduce our progress in the past 2 months, I suppose. And we have actually achieved a good success. Although we did not find all the bugs reported, but still, we find 41 issues instantly reported after the integration from OSS-Fuzz, and we have resolved 21 of them, which are confirmed as bugs. And for the bugs fixes, actually, the integration of OSS-Fuzz, integration actually helped with over 5,000 line of code changes for the overall code in the Open Printing project, which demonstrates the effectiveness of the OSS-Fuzz. And the bugs detected are actually useful to help with the development of the open source software. And we also enable the fuzz introspector to support the LLM-assisted fuzz driver generation, which we are still currently working on. And I suppose Dongge will later on introduce the details of the OSS-Fuzz-Gen. Yeah, it's very useful and powerful tool. So regarding the advanced fuzzing integration, actually, I suppose for open source developers, you may have different characteristics of your own software, which are different from Open Printing project. And what I want to mention here is that first, you can always start from just migrating the existing testing, which already contains the matured calling traces of the functionalities of your software into fuzz harness. So it can be the most simple one. And actually, LLM can also help you with that steps as well. So you can choose either ways. And also, you should consider different test input format, which actually it may influence the design of the fuzz harness and also the fuzz driver you are selecting. So for example, in Open Printing, we have IPP protocol, which we can reference this question can be formalized as a protocol fuzzy. The goal is to design a format or a template for us to mutate from, and we want to find the violation input that may trigger the crash or vulnerabilities in the software. And also we got PDF files and different format of files, including PDFs, I think for images as well. So so Open Printing project will process these files. And what I mean here is that you can also consider mutating based on file levels, you let the FL or other fuzzers to help you generate a different type of different type of the files, and yeah, it can also mutate based on the format. And also we consider like the argument, like the command lines. We just need to test like for existing provided command lines if there are some like parsing issues or other steps. So that's actually some point we should focus on during the integration, and that's from my personal experience. And also, I strongly suggest you to, if you want to integrate your project into OSS-Fuzz, then I suggest you to integrate the fuzz introspector as well. I mean, just fix with some building issues. You can do it locally, and then I think it can largely help you to integrate your project with the help of OSS-Fuzz-Gen, which may, I think, from my perspective, will release a lot of your time from building like dumb harnesses into just real practical design of the fuzzers. Yeah, and lastly, as I think mentioned by Dongge and also mentioned by Andrew, that it is suggested to post your harnesses outside of the OSS-Fuzz framework itself, but just do it on your like individual repos of your software project. So for the other like advanced integration techniques, you can check with our own integration. It's just a very simple link you can access where open printing fuzzing, and you can find like our harnesses together with our build script, our documentations for triaging and integrating new projects. Yeah, you can learn a lot from the project, and yeah, I just put the link here. And that's all for my integration of my own experience. I think later Dongge will proceed with introducing the OSS-Fuzz-Gen framework.
Yes. So, may I switch to?
Yeah.
Okay. Cool. Yeah. Thanks. So, the idea of OSS-Fuzz-Gen is to fill in a gap currently in OSS-Fuzz. Recall OSS-Fuzz was initially designed to reduce the manual work of fuzzing, but there is one thing missing, that is writing the fuzz target. George-Andrei and Andrea were very nice in providing the target CC for us, but in reality, it takes a lot of time and expertise to write that file. So this is a comparison. So for human to write a fuzz target, they will need to learn the background of fuzzing, the basic knowledge of fuzzing. They also need to read the project source code to understand where the vulnerability could happen. And they will also need to spend hours, if not days, to write one fuzz target. So that's very manual intensive. So OSS-Fuzz-Gen was designed to reduce the burden of that. So it has pre-trained LLM with fuzzing knowledge, so that we don't have to learn everything about the fuzzing. It programmatically supply project source code context in prompts to LLM, so that we don't have to read every line inside the project source code. It will generate a fuzz target in seconds, and the cost of it is just the same as a normal LLM query, right? So since it has been released last year to date, it has uncovered 26 new bugs in projects. In these projects, including that CVE, and it has managed to increase code coverage in more projects. Next year, we'll officially roll out OSS-Fuzz-Gen in more projects in OSS-Fuzz. So if you are interested in seeing these features and experience them, please go and talk with us. Right, here is a peek on its overall structure in case you're curious how it works internally. So for given a project in OSS-Fuzz, OSS-Fuzz-Gen will pick a function inside the project and supply the function with its contextual information to LLM, so that the LLM can give us a fuzz target. And with the fuzz target, OSS-Fuzz-Gen will try to build and run the fuzz target like what you did with the OSS-Fuzz infrastructure. And with the raw output from OSS-Fuzz, OSS-Fuzz-Gen will manage to identify if there are any crashes, or if there are any build errors, or if there are any lack of coverage in the functions under test, and they can feedback that message to LLM, so LLM can help us refine the fuzz target. So this feedback loop will automatically try to improve the fuzz target over iterations. This doesn't require human intervention at all. So yeah, that's it.
So, can we? Yeah, this being said, I want just to wrap up this by looking again at the agenda, namely the things that we discussed today. We have looked into what fuzzing is and how does it work internally. We learned about OSS-Fuzz. We have practiced OSS-Fuzz by discovering Heartbleed. We had an awesome tale from Zhongxi about his integration, and I want just to mention that he is in California now, so 4 a.m. in the morning. So Zhongxi, really appreciate that you entered this talk. And we also had some insightful description about how LLMs are used nowadays for generating fuzzing harnesses. This being said, I hope that you like this. I hope that you are leaving the room with some more insights about fuzzing. I hope that the fuzzing will not be any more a taboo subject. And if you have any project that can benefit from fuzzing, please submit some PRs to OSS-Fuzz. Thanks.
Awesome work. That's really cool that you found 41 bugs so quickly. Of those 41 bugs, were any vulnerabilities and have CVs been assigned?
I don't think so. Most of them were timeouts or other non-security issues. I think there was only one memory corruption, but I think that the maintainer didn't assign a CV for that. So we are still waiting for the memory corruptions, which can have some CVs assigned.
Yes, these bugs Mike Sweet has simply fixed directly.
Yeah, yeah. And I need to admit that the open printing guys are really fast in providing some patches.
But I must also thank the security team of Canonical. They were also really, really fast in getting our fixes into Ubuntu when we had to emergency disclose the RCE bug.
Yeah.
So even for kind of the older issues that were vulnerabilities, if you can add a CVE even like after the fact, because for a stable release of software, like in Ubuntu or in Fedora or whatever, we won't get those patches backported unless there's a CVE. So like if you're running the latest version of the software, you would get the update. But otherwise, we wouldn't know to update the software for those patches. So that would be awesome if you could also do that.
Yeah, but the condition here is to have some security impact, because we have seen in the industry that there are a lot of bogus CVs for things which doesn't really have a security impact. So it's useless to just create some CVs for having some industry rewards and for you guys to have more work to do for nothing. So if there will be some security impact, be sure that we request some CVs.
Cool.
Any other questions? Otherwise, that's all. Have an awesome day, guys.
And Zhongxi, are you hearing me?
Yeah, I can hear you.
Yes.
So
Yes, thanks a lot for staying awake at this unhuman time at your place.
Really?
It was great
Thank you
that
so
you have
much.
joined here and
Come here.
reported about your Google Summer of Code work for OSS-Fuzz deployment and open printing.
yeah, thank you. Thank you for hosting the event. Yeah, actually, I just arrived, so just the time jet. Jet lag. So the similar time in Singapore. is
Helping
actually
you
quite
that today that it was not so bad for you today.
Yeah, sure, correct.